Hello everyone, and today's topic of discussion is elasticity. I am welcoming you all in today's class. So let's start. Now, what is elasticity? Elasticity is a property of material, any kind of material, due to which, or we can say by virtue of which, the material regains its original or initial shape or size after getting some amount of deformation. Okay, so that means when you are actually applying some amount of force on a rubber band and just stretch it out, just stretch it. Now release the thing, you will see that will again regain its original shape. It will come back to its original shape. So that is the due to elasticity. That is all about the elasticity. Okay, so again we can say that in conversely, so this is also the amount of resistance that actually provided by the material when we are going to change its shape or size. Okay, so that means this is the amount of resistive force it provides to anyone who is going to change its size or shape. Okay, so that is the elasticity. So we can actually describe the thing very much. Now, to start with, let's assume, so every material got some atoms, and the atoms are attracted by the neighboring atoms. Okay, so that means all atoms are connected. This is our assumption. So the assumption is that all the atoms are connected by a spring with the neighboring atoms. Okay, so this is our assumption, and the force of attraction between two atoms is actually described by using this force. Okay, by using this spring connected between two atoms. Okay, so this is the things. Now if you want to stretch this thing, so you have to put some amount of force. So what will happen? So these atoms will move away from each other. So that is the elongation. Okay, so these atoms, all the atoms will move from each other, and that's how the elongation will produce. Now if you just leave this material, that means if just you withdraw the force, this spring will start to work, and what will do they? During the elongation, the springs actually stretched. Now after retrieving the force, this spring squeezes to their initial position, squeezes to their initial state. So that means this all atoms will come to their initial position, and the material will regain its initial shape or size. Okay, so that's how elasticity works, and that means the elasticity is mainly due to the fact of the attraction force between the atoms in any material. Okay, so the more stronger the atoms are bound, the elasticity of the material will be larger. Okay, so that is the elasticity. So from this context we can actually can get some idea about steel and rubber, which one has the more elasticity or which one is more elastic. So maybe we can think about the rubber. So rubber is more elastic because it stretches more, but not the thing. Actually steel is more elastic. Big reason is that, so according to the idea of elasticity, what is the elasticity? It is the property by which object gains its initial state, or object regains its initial state or position, or it comes back to its initial state. So that means how the object that quickly regain its initial state has a more amount of elasticity, and that will actually provide you more amount of resisting force when you will try to stretch it out. So in comparison with rubber, the steel is more elastic. Reason is already I just mentioned you. Okay, so this is the reason why the steel is more elastic than the rubber. Okay, because steel actually regains its initial state or initial position very quickly compared to the rubber, or it actually provides more resisting force when you try to stretch it out. Okay, so now two basic terms there, those are related to the elasticities. One is stress, another one is strain. Now what is stress? Stress is actually, you know about these things. If you want to pull the things, that means you want to stretch the things, you have to put some amount of force or some amount of load on it. So that is the stress. Stress is actually defined as the force per unit area or load per unit area. Okay, so that has the unit Newton per meter square or dyne per centimeter square, and so the unit or the dimension of the stress is actually same to the dimension of the pressure. Okay, so that is also force by area. Okay, now what is strain? Strain is actually amount of deformation within the object. Okay, so that is the measure of amount of deformation or amount of stretch within the object. Okay, so now a material, for any material, if we plot the stress versus strain curve, we will get some variation that I just shown here. Okay, and the complete experiment was, or mainly the complete experiment is used to done in a machine called UTM, that is universal testing machine. Okay, so where tensile stress is applied on any object and the strain is measured. Okay, so actually it's not tensile stress, that a load, tensile force, that is a load is used on the object and the strain is calculated in the machine. Okay, and with which we draw this graph. Okay, now if you see, there is a linear relationship between stress and strain. There is a proportional region for a very small value of the stress. Okay, so this region is called the elastic limit. Okay, and after that there is a region, non-linear region, and this region is called plastic limit. Okay, now within the elastic limit you can see this is a straight line, that means the stress actually varies with the strain proportionally. Okay, and that's sometimes called Hooke's limit. Okay, now after that there is a certain plateau type region, and where B and C, there are 2 points. Okay, now if you check this for this 2 point, you will get from B to C the stress has not changed yet, but the amount of strain, it is changed. Okay, so it has changed. So that means the material is changing its shape without being applied more amount of stress. Here it not, stress is not zero, but I am not increasing the stress. I have given a fixed amount of stress, and with which the object is continuing the stretching. It is being stretched. Okay, it is continuously being stretched. Okay, this is the thing, and this is the region where the elasticity of the material suddenly collapses. Okay, so if you just from the point C, that means if you are on the point C, now if you just bring down the stress, that means just withdraw the stress, so strain must go down, strain must reduce. So if you keep on reducing stress and it bring to zero, you will see the strain is not till zero. So that means finite amount of strain is permanently introduced to the material. So that means a permanent stress has been introduced to the material. Okay, so that means the idea of elasticity, where we always say about the material will always regain its initial state, that thing actually gone. Okay, so that means the material is permanently stretched or permanently elongated. Okay, so this point B or C, these 2 points are called yield point, and B is called the upper yield point and C is called the lower yield point. Okay, now if you then check again, with increasing stress, strain has been increased, and D is the point where the material strikes where the material takes the maximum amount of stress. Okay, this is the maximum stress and it is called ultimate stress. This is the maximum amount of stress that a material can withstand. Okay, and again next you can see the stress decreases but the strain has increased. So at the point E, a fracture will occur to the material. Okay, so that means E is the fracture point, and from D to E, this region is called the necking. Here a phenomena has happened, a phenomena happens usually that calls necking. Okay, so this is the thing, this is all about the stress versus strain curve. Now we will directly jump to the Hooke's law that says within the elastic limit, that means we are in the proportional region, within the elastic limit, stress is directly proportional to the strain. So that means stress by strain is constant, and this constant is called elastic modulus. Okay, so we have basic 4 elastic modulus, mainly 3 elastic modulus and one is called Poisson ratio. So first one is called Young modulus. Okay, and it is directly related to the stretching of a material. So elastic Young modulus is defined as the ratio of longitudinal stress to the longitudinal strain. Okay, now what is longitudinal strain? Longitudinal strain is the elongation of the object. Okay, now let the object has an initial length of small l, and due to application of force, its length has been increased and it becomes L plus delta L. Okay, so then means change in length is delta L. So the longitudinal strain is defined as the change in length divided by initial length. This is a ratio term. So that means the strain doesn't have any kind of unit. So that means longitudinal strain will be delta L by L. So your Y will be F by A. That is your stress. Okay, stress is your force per unit area. So this is force by area divided by delta L by L. This is your Young modulus. Okay. Now next one is bulk modulus. Okay, so Young modulus is important for the solids. Those have the length to increase. That means also liquid or gas, the length of liquid or gas increment of that is not logical. Okay, so the Young modulus is related to the solid. Now for what is bulk modulus? Next one is bulk modulus. So bulk modulus is actually ratio of volume stress to the volume strain. That means it is all about the change in volume. So again the volume stress is again force by area, and volume strain again like the previous one, change in volume divided by initial volume. So bulk modulus is B equals to, B will get some kind of this equation. Okay, so with the bulk modulus we define another term called compressibility. What is compressibility? Compressibility means how much an object is compressible, means how easily you can compress a thing. That actually reflects in the term compressibility. Okay, and it is actually 1 by B, inverse of bulk modulus. Okay, now third elastic modulus is rigidity modulus, and it is defined as eta, and that is shear stress by shear strain. Okay, so this is ratio of the shear stress to the shear strain. Now what is shear stress? So mainly we actually define the stress into two categories. One is normal stress, another one is shear stress. So normal stress is a stress that is applied on a surface perpendicularly. Okay, so that is called normal stress, and shear stress is a kind of stress that is applied on any surface tangential to the tangentially. Okay, so actually size that means the volume, length or area, that is actually changed due to the application of the normal stress. But by the application of the shear stress we can modify the shape of the object. Okay, so here I have given an example. Okay, so there was a rectangular, sorry, not rectangular, there was a parallelepiped, that is a box. Okay, and we are getting a side view of the box. Okay, now I have applied a shear stress. You can imagine this is shear stress, since this force is tangential to the this surface, and this force is actually acting on this surface, the upper surface. So and the force is tangential to the upper surface, so that's why this stress is actually shear stress. So that will move the upper surface in its direction, keeping the lower surface fixed. So that will actually produce a deformation or change in shape rather than size, change in shape. And this is called this is how shear stress actually works. So now rigidity modulus is all about the changing of shape. So rigidity modulus is given by the shear stress by shear strain. Shear stress is again this force by area, but shear strain is the amount of angle that with that angle the material has deviated. That means uh, this is the amount of angle to which any vertical line within the material actually slanted. Okay, so that is the rigidity modulus. So this theta is your shear strain, and you can find the tan theta, that is your height by base x by L, or you can assume this theta is very small, so tan theta can approximate it as theta. So theta you will be x by L. Just put that here and you will get the value of eta. So the fourth elastic constant is the Poisson ratio. That is not elastic modulus, since it is not stress by strain like the previous ones. So it is mainly the ratio. Why it is called ratio? Mainly it is a ratio of two strains. One is lateral strain, another one is longitudinal strain. So from our simple basic idea, we can understand the thing. If you elongate, if you stretch a wire, if you stretch a rubber band, you will get this, the band becomes thinner. Okay, so the band becomes thinner. So as you keep on going, increasing its length, it will keep on going thinner and thinner and thinner. So that is the idea about the Poisson ratio. Okay, that is the lateral strain divided by longitudinal strain. Lateral strain means how much deformation it has got in the lateral direction. Lateral direction means in its cross section. Okay, so that is defined like that. So lateral strain is defined like dd by capital D, that is the change in diameter divided by initial diameter. Okay, so instead of using cross sectional area, just diameter has been used for a wire. Okay, so D is actually diameter of the wire, and longitudinal strain, as we all know, that is your dl by L, where dl is the change of length and L is your initial length. So Poisson ratio will get this kind of value. Now for any real material, the Poisson ratio must have a negative value. Reason is, if you keep on going increasing the length, that means your dl is positive, you will get a thinner and thinner material. That means your diameter will reduce. That means your dd, change in diameter, will be negative. So ratio will be a negative quantity. Okay, so Poisson ratio must be a negative quantity, but as we know this is a negative quantity, we actually use it as a positive value. Okay, so real value that is used for the Poisson ratio is 0 to 0.5. You can see this all are positive value. So we know about this thing is negative, so we use it as a positive. Okay, so this is the idea. And when you actually instead of stretching, if you compress the thing, that means your length is decreasing, that means your dl is negative, you will get a thicker object, that means your radius or your diameter of the object will increase, that means your d of d, change in diameter, will be positive. So one thing between these two strain, one will be negative, another one will be positive at a time. So that means the Poisson ratio must have a negative value, and so we know about this thing, so we use it as positive. Okay, now next one is the elastic potential energy stored in any elongated object, so that we want to calculate. So now the length of the wire is capital L for that time, and we are applying a force capital F, and due to which the wire is elongated by a length small l. Now there is a long story behind it, why we are taking average force. So that is not directly, actually force is applied force, is not actually the stress is mainly the reason of the force, sorry, stress actually comes due to the application of force. Okay, so this is a complicated thing, so just for the timing just skip it. So just so so the work done will be your F by 2, that is the force multiplied by distance displacement. F, so W will be your half of Fl. Now Young modulus, as we know, Y equals to F by A divided by small l by capital L, and from that we get capital F is YL by A by small capital L. Okay, just put the value of F in the equation. Now energy stored per unit volume of the wire. How will we get this thing? So that is W by V. V is the volume of the material. So this is length multiplied by the area is volume. So A, both the A will cancel. Now you will get half of YL capital L multiplied by the L by capital L. This term is the strain, change in length divided by length, initial length. This is your strain, and YL by capital L. Just take a look from here. YL by capital L is your F by A. So that is your stress. So the amount of energy stored per unit area of a wire is exactly equal to the half of stress multiplied by the strain. Okay. So that's the end of our today's discussion. Thank you.